Hello, you're welcome once again to my YouTube channel. This is the channel where chemistry is dissected, where chemistry is broken down, where chemistry is thrashed in such a way that it will be so easy for you to understand. If you're just joining for the first time, please hit the subscription button and then press the notification bell near it so that anytime I post new content, you'll be able to receive it. And also for my returning subscribers, those who have already subscribed, I thank you so much for believing in me, and I promise you will not be disappointed with this my YouTube channel. So today, what we are going to talk about today is elements. All about elements. We have been hearing of elements. We have elements in different capacities. Yeah, electric bulb contains what electricians call elements, and so on. And there are so many different types of elements. But today, the one we are going to discuss today is elements involved in chemistry. Now, in our previous video, I talked about matter. So it's still a kind of continuation of matter. Matter is classified into elements, compounds, and mixtures. Yeah, matter is classified into elements, compounds, and mixture. An element or compound is a pure substance. They are considered pure substances because they cannot be separated into more than one component by any physical method. That is why they are considered pure substances. However, not all of them are really pure, as it's meant to believe. Not all are really pure. Some contain impurities. So these ones that contain impurities are the ones that are called mixtures. So that's why it is normally said sometimes a mixture, it consists of more than one element or compound, and they can be separated by physical methods. Now, how do we define element? An element is a substance which cannot be split into simpler units by ordinary chemical process. It cannot be split into simpler units by ordinary chemical process. In other words, what it means is that it has to be an extraordinary process that can be able to split an element into simpler units. So it's almost an impossible feat. Or I said almost an impossible feat. These elements constitute the building units of all other substances. That means all other substances, chemical substances in chemistry, have their foundation as elements. Elements is their foundation. Like compounds consist of more than one or two or more elements, not one, two or more elements. Now, there are up to 109 known elements. Known ones, that means there are still others that are not yet known, but the known ones are 109, of which out of these 109, 90 of them occur naturally. That is, it means that they are found in nature without any artificiality in them. 90 of them occur naturally, while the remaining 29 are made or prepared artificially in the lab. These elements are represented chemically by symbols. For example, oxygen is represented by O. Nitrogen is represented by N. Sulfur is represented by S. Sodium is represented by Na, capital N and the small letter A. Capital N and small letter A. That is how sodium is represented. Potassium is represented by K. So these symbols help us to easily know the particular element that we are talking about. It helps to easily identify them. These elements, they are grouped in the form of a periodic table. For easier understanding, they are grouped in the form of a periodic table. There are 6 types of elements. In this periodic table, there are 6 types of elements. We have the reactive metals. We have the reactive metals. We have the transition metals. We have the lanthanides and the actinides. Lanthanides and actinides. We have the pure metals. We have the non-metals, and we have the noble gases. Listen again. Six types of what? Elements. Number 1, we have the reactive metals. Number 2, we have the transition metals. Number 3, we have the lanthanides and the actinides. Number 4, we have the pure metals. Number 5, we have the non-metals. And number 6, we have the noble gases. Elements are also grouped. We just talked about their types. Now they are grouped, classified into metals, metalloids, or semi-metals. That is, part metals and part non-metals. That's what they mean by metalloids or semi-metals. And then we have the non-metals. 3 groups, classified into 3 groups: metals, semi-metals or metalloids, and then the non-metals. The metals are those which ionize by electron loss. That is, they give out their electrons. They are not selfish. They are so generous. Metals are very, very generous because they are looking for who to give out their electrons. So they lose their electrons in order to ionize. Examples of metals include sodium, potassium, calcium, magnesium, etc. You still come to that. And then with the non-metals are those ones they are never satisfied. The non-metals are never satisfied. They are always looking for metals, always looking for the elements in order to add to their own. So they ionize by gaining elements. They gain electrons. Sorry, electrons, not elements. They gain electrons in order to ionize. So the non-metals gain electrons in order to ionize, while the metals lose. So examples of non-metals include chlorine, oxygen, nitrogen, iodine, etc. Then difference between the physical properties. We now come to their properties. We have the physical properties and then we have the chemical properties. Now for the physical properties of metals and non-metals, the difference between the physical properties. Metals are malleable, ductile, or sonorous. Just like I explained what malleable means in the other, in the last topic I discussed. I talked about malleable. When it means they can easily change shape. For example, when these metals are heated in a way that they become a bit soft. When they are now soft, they can be turned. The shape can be turned into any shape, any desired shape. That is what they mean by they are malleable. They are ductile. They can easily be stretched, and they are sonorous. Why non-metals they are not like that. They are not malleable, they are not ductile, they are not sonorous. Then we have the metal. So that's the first one. Second one, metals have great tensile strength. That is, they are strong. Metals are strong. You can't just easily break a metal. No, who are you? You cannot easily break a metal. They are strong. While non-metals are brittle, they are soft. They can easily brittle means that you can easily break it up. They are brittle, they are soft, they are not hard. Number 3, metals are lustrous. That means the metals are attractive to behold. When they are new, not when they have become rusted. When they are new, they are shiny, lustrous. They look very attractive. While non-metals are not. 4, metals have high melting and boiling points. It takes a lot to be able to break down the molecules holding more metal. You need a great heat, very great heat, in order to break down those molecules holding the metals together. So that's why it's said that they have high melting and boiling points, while non-metals have low melting and boiling points. Metals, however, carbon is a non-metal and it does not have a low boiling and melting point. So with the exception of carbon, non-metals have low boiling and a melting points. Metals have relatively high densities, while non-metals do not have high densities. I'll go through it again. Non-metals have low densities. Metals are malleable, ductile, or sonorous, while non-metals aren't any of this. Number 2, metals have great tensile strength, while non-metals don't. Number 3, metals are lustrous, but non-metals are not lustrous. Number 4, metals have high melting and boiling points, but non-metals have low melting and boiling points, except with the exception of carbon. Number 5, metals have relatively high densities, but non-metals have low densities. That's the physical properties. Now we come to the chemical properties of metals and non-metals. So we are also going to put it in the form of difference between the chemical properties of metals and the chemical properties of non-metals. Number 1, metals are reducing agents, or you can say they have that's why they are called reducing agents, because they have the tendency to ionize by giving out their electrons, by losing electrons. That is why they are called reducing agents. They are reducing agents because they have the tendency to ionize by losing electrons or giving out their electrons. Why non-metals is exactly opposite. They are the oxidizing agents. They are called oxidizing agents because they have the tendency to ionize by gaining electrons. They have the tendency to ionize by gaining electrons. Number 2, metals are basic oxides. They form basic oxides with oxygen. Metals form basic oxides with oxygen, while non-metals form acidic oxides with oxygen. Metals form basic oxides with oxygen, while non-metals form acidic oxides with oxygen. Number 3, reactive metals can displace hydrogen from acids. Note it, not all metals, the reactive ones can displace hydrogen from acids, while non-metals cannot in any form displace hydrogen from acid. And number 4, metals generally form ionic compounds, while non-metals form covalent compounds. Metals form ionic compounds. Those compounds are dissolved in water to form ions, while non-metals form covalent compounds. Most covalent compounds are not soluble. So with this, I believe we've touched elements, all about elements. So with this, we have come to the end of this particular topic. I hope you got a lot from what I taught. See you next time.